With this presentation, I would like to share with you what I learned during this fellowship that I completed with XR Access, during which I created a caption system for virtual reality in Unity. So you're all probably aware of captions or subtitles. They are both similar. Subtitles are often for translating dialogue in movies and TV shows, but captions often focus on ensuring that dialogue and sound effects and music are accessible to people who are deaf or hard of hearing. When it comes to 2D media like television, captions and subtitles are commonplace. We could call this kind of subtitles 2D subtitles. And this is because they're meant for flat screens. 2D captions are relatively straightforward when it comes to implementation. Since the viewer is always looking at the screen, like a single point in space, captions can be placed at the bottom or the top of the screen. And moreover, 2D captions have been around for decades, which means that there are a lot of established guidelines and best practices when it comes to implementing 2D captions. Aside from TV and movies, 2D captions are also common in video games and other interactive media that is meant to be consumed on a flat screen. Now let's talk about captions in VR. When it comes to VR, captions are also important to ensure that experiences are accessible to people. But unfortunately, captions in VR are not that widespread. And this is because captions in VR are more challenging to implement than in 2D. There are a number of reasons for this. First, users in VR are not always looking at a single point in space. They have the freedom to look around, and they can look behind you, and they can literally look anywhere in the 360 degree of freedom that they have. So where do you put the captions? There's no easy way to answer this. This is the problem of positioning captions in VR. There's also scenarios to think about, like what if there's a speaker behind you, and what if there are multiple speakers? The problem is not that there's not a solution to this. There are plenty of solutions to the problem of positioning captions, but there is no single solution that's guaranteed to work everywhere. Let's have a look at a few examples of how other developers have solved this problem of positioning captions. This is a video from the popular game Half-Life Alyx. And here you can see that when the user is looking around, the captions follow their head wherever they go. And this is quite a simple solution, and these are called head-locked captions. Now let's look at another example. This is from a game called Vacation Simulator. And here the caption initially appears above the speaker on top of their head. But if you look away, then the captions follow your vision. So it's kind of a hybrid of normal captions versus like head-locked captions like we previously saw. Now, the two examples that we saw here illustrate two different ways to approach the problem of positioning captions. However, each solution has their own drawbacks. For example, in the video that you're seeing here, you can see that the captions move with your head. There's a lot of motion, and this might cause problems for people who have motion sickness. And in the previous example with the headlock captions, the problem is that captions always appear in the bottom half of your display, so you have to always look down. So it will be difficult to focus on what you're looking at. Now, the effectiveness of a positioning method often depends on the context of the VR app that you're developing. So you really have to think about what kind of positioning method works best for your captions. Now, let's take a look at a different problem. That's the problem of the developing captions. So VR captions also pose a number of development challenges. VR developers often have to start from scratch when implementing captions, and they have to identify what kind of captions work best for their app. As we saw before, you cannot just place some text on the 2D screen. You have to actually program how the captions appear in 3D and then move to accommodate other things. There's also a different problem. But before that, let's take a look at one of the virtual reality texts. So Yuvraj already talked about the VRCs. This is a different VRC from Meta, which is a recommendation for apps that are published on Meta's App Store. And they say that applications should be playable in its entirety without the use of audio by providing subtitle options or like for dialogue and sound effects. Now, Meta gives its recommendation, but unfortunately, they don't give any example code or resources to developers to easily implement captions. And there's also a lack of existing resources from third-party, from both first-party and third-party developers. Now, that was a problem of the development of captions. Now, let's take a look at a different problem. That's the problem of customization. We saw that different positioning methods work differently for different apps, but we also have to think that each user has different needs when it comes to captions. The font size, for example, how a caption appears, doesn't necessarily have to be the same for everybody. So people need to be able to adjust exactly how captions appear in the app. So the font appearance, like the font size, color, outline. Then some people might also need a background for readability. And if somebody has motion sickness, they need an option to reduce the number of animations and captions moving around too much. And finally, we also need to think about different languages. So some languages like Arabic, for example, have right to left text, which means that the normal way of rendering text in Unity probably doesn't work in that case. So there's a number of customization aspects that need to be, we need to think about when developing captions. So during the fellowship that I did at XR Access, I worked on Chirp captions. Chirp is the name, it's just a random name we came up with, but it's a package for Unity that lets developers easily add caption support to their VR apps. Chirp aims to be an example of how captions can be implemented by providing developers with actual code and reusable components that they can use in their own apps. And most importantly, Chirp is open source so that anyone can see how it works and use the code in their own projects. Let's have a look at an example of how Chirp works. So here you can see that I am launching a demo app that I created using Chirp. And this is just a simple app where there's a number of characters speaking and captions appear corresponding to their dialogue. So here you can see that there are 3 different animals and they all have different voice lines. And when each one speaks, the caption appears at the bottom half of your display. Now, this is quite similar to the example that you saw previously with Half-Life Alyx, in that these are headlock captions. They follow your head wherever you look. Here you can see that there are little arrows that point to where the speaker is. So it's a way of determining who is actually speaking based on the captions. And you can also see this panel with a lot of settings. This is a pretty complicated panel at first, but this is just a demo to show you what Chirp is capable of. So you can see that you can change a lot of the aspects of the text, like the font, the color, the font color, the background color, and even more options. There's also the option of like, how quickly does the caption follow your head? You can make it slow, or you can make it as fast. Making it fast might mean a lot more motion sickness, so maybe a slower setting works better for you. That was a quick demo of Chirp captions in action. And let's talk a bit about the features of Chirp. Importantly, that Chirp is a Unity package that anybody can download and integrate into their own Unity projects. So it's quite easy to integrate Chirp into your own projects. Chirp also supports multiple positioning modes. At the moment, it only supports headlock, but there's the possibility to add on different modules to it. So each module builds on the framework, the base framework of Chirp. So it's quite easy to add a new positioning mode to Chirp. Chirp has a lot of customization options, like you saw before. And Chirp has support for scripted and real-time captions. So scripted captions mean like you already have the caption text. So for something like a cutscene in a game, for example, you already know what they're going to say. So you can pass on the captions as text. With real-time captions, you can use an external voice recognition software to actually transcribe the captions and then pass it on to Chirp. Chirp is also versatile and extendable so that any developer can look at the code and add any features that they want. And It's Chirp is released under the MIT license. It's a really permissive license, which lets you do whatever you want with the code, and you can also publish it as part of your closed source apps. Now, I'll walk you through the steps of integrating Chirp in your Unity project. It's just a quick overview, not covering all the steps here, but just to give you an idea. So Chirp can be downloaded as a package from GitHub. You can just paste the GitHub link into Unity and it will automatically install it. And then Chirp comes with a handy prefab that you can add to your main scene. And this adds the functionality of Chirp. Then you can add a caption source script or a component to whatever object that you want to have captions. So if there's a speaker with a dialogue, then you can add a caption source component to them. And finally, you can call some functions on that caption source. So this is a simple example of a function where you can show this text for 3 seconds. Now, when it comes to the future work of Chirp, Chirp is still a work in progress. One of the main goals of Chirp is to make code and examples related to VR captions more widely available. So it's an open source project where the community can actually contribute to making Chirp better. So, and it's also meant to persuade platform owners like Meta to provide better documentation examples. So if there's more interest in VR accessibility features like captions, then this can persuade owners like Meta to up their game and make more resources available. Chirp was also a lot of learning for me. It was a great opportunity for me to learn about accessibility in VR. I feel like accessibility features for VR do not get the attention that they deserve, and more resources need to be allocated to them. This was a great opportunity to learn about that. Then there's also the open source aspect. This was probably the first open source project that I actually contributed to. I've used a lot of projects like Blender and a lot of software that is open source, but never actually got the chance to contribute back. So this was a great opportunity for that. Now, also another point to note is that there are a lot of existing games out there that have caption implementations for VR, but they're all closed source, but so that nobody can look into how they work and use them in their own apps. So for accessibility, open source is definitely the way forward. There's also a need for best practices and guidelines. Now, groups like the W3C Immersive Captions group are doing a lot of great work in this regard in terms of coming up with standards for VR captions. And this fellowship was also a chance for me to actually participate with the W3C group meetings and give my inputs on that and be part of that community. And talking about community, I think community is a really important aspect when it comes to accessibility and creating sustainable apps for accessibility. It's really important to build up that community and make sure that the people involved are actually really motivated to work on these problems, either because they suffer, like they have these problems, face these problems themselves, or because they want to use their skill to solve problems in accessibility. Yeah, that was my presentation. Thank you everyone for watching. And if you have any questions, please feel free to ask them in the chat.
Excellent. Thank you so much, Savio. And yeah, thanks for really illustrating and making the point on the open source nature of this work. I think that's really important. And I agree, for accessibility, we want to make this as easy as possible. So that was a really cool part of working with XR/OS, with this whole idea that everything that you all have built is available for people to take and customize, and the license you mentioned. All right, we have a few questions. Let's take the question first from Claudia. Hello, do you know if there's been any work on possibilities of creating captions for those that are deaf and blind using haptics or Braille, perhaps?
Haptics and Braille. Yeah, during the short time that I spent on this project, I did not come across any such projects. But it's definitely interesting because haptics is a different media. Like it's not this. So captions here is just a visual thing. It's just something that you see on your headset. But then being able to actually physically interact with text in a way is an interesting problem. And I haven't thought a lot about that, to be honest. So I cannot really give you an answer for that. But it's definitely an interesting subject, I think.
I agree. Interesting question.
Yeah.
Next, with Chirp captioning, how can you make the distinction between what or who is talking at any time, especially if more than one character is speaking at the same time?
Yeah, that's a good question. So when it comes to captioning for VR, speaker identification is a really important aspect. There's multiple ways to approach this problem. So in the headlocked captions example that you saw before, let me see if I can quickly, or maybe you can also just have a look at the Half-Life Alyx example. You can see that each caption has a name preceding it, so that shows you who is speaking. That's quite a simple solution that's also often used in 2D captions that can also be used in 3D or VR. So in the example that I showed you, the demo, you probably noticed these little arrows which point to the speaker who is speaking. That's a different solution that also lets you know in like a spatial way, like who is speaking. So you can like turn your head towards that direction if you want to see that speaker. There's probably also different ways to do it. Yeah, like maybe I'll have a look at the next example, and here, oh, yeah, here you can see that the captions have a little icon next to them. It shows you a little picture of who is speaking. So it makes a lot of sense in a game like this, where you probably are already quite familiarized with the characters. So a little icon is all that's necessary instead of a name or, yeah. But here you can also see that those little arrows. So there's multiple ways of approaching this, and it also depends on the positioning mode that you're designing.
And let's just read a comment too from chat from Dylan Fox from XR Access. Going back to the comment on the Braille display, we need to ensure that the text input from the captions could go to a Braille display or something similar. Depends on how that text is produced and whether that output can be tapped into, I think. So yeah, maybe just some other thinking on if you make the text stream implemented in the application, can you make it available to like another application or like a hardware device to get access to it? Well, I want to say thank you so much, Savio, for your presentation. And again, as said with the previous, feel free to reach out to Savio for his work. And we are posting, a full article on the Ecology website with the instructions on installing and using Chirp captions, so you can actually try implementing Chirp captions on an existing application and learn how you could put it in your own application.